we are going to attempt to define dimensional weight. What does it mean? How is it calculated? We'll get into some examples relative to that. We'll talk about why carriers use dimensional weight, why it's so important to them, and why they've expanded their use of it over the past couple of years. And then we'll talk, maybe most importantly, why does it matter to shippers? And what are some things that shippers can do to not only understand better how dimensional weight impacts them, but some steps that they might be able to take to mitigate the impact of it to them. So what is dimensional weight? At a very high level, the dimensional weight of a package is a calculated, or theoretical is another way of looking at it, theoretical weight of a package based on the package dimensions, so length, width, and height. This theoretical weight is designed to allow the carriers to achieve a minimum package density. Now that's a very high level definition, and we're going to get into some of the aspects of this definition in a little bit more detail shortly in terms of how it's calculated and why package density is so important to the carriers. But again, at a high level, the important thing to remember is that dimensional weight is a theoretical weight. It's not the actual weight of a package, it's theoretical. It's calculated based on package dimensions and a few other factors that we'll talk about shortly. Dimensional weight can and usually does differ from the actual weight of the package, and that's why carriers use dimensional weight, because it's a weight that's different from what the package actually were to weigh if you were to put it on a scale. And because there is a difference generally between the two, carriers will use the greater of the two, the actual weight or the dimensional weight, to determine the rate for that package. So if you think about how carriers bill for package shipping, they bill by weight. So if the dimensional weight happens to be greater than the actual weight, they're going to use that dimensional weight to determine the rate of the package. And again, we'll get into some examples here shortly. Carriers, especially UPS and FedEx, use dimensionalization or dimensional weight on just about every package that they carry today. It was not always that way. Prior to 2007, carriers were dimensionalizing international packages. They were dimensionalizing some domestic express packages. They were not dimensionalizing ground packages. So prior to 2007, UPS and FedEx were using what they called OS designations, OS1, OS2, OS3 on domestic ground packages. But those OS designations were reserved primarily for very large, very cumbersome packages. And I don't have those measurements handy, but it was designed to allow the carriers to get compensated for carrying very large packages that sort of clogged up the network. It was after 2007 that the carriers really started to expand the use of dimensional weight. And currently, both UPS and FedEx will apply a dimensional weight formula to every package that they ship using the same dimensional weight divisor. So domestic, international, domestic express, etc. Everything is dimensionalized these days. So let's talk a little bit more about how the carriers calculate dimensional weight. As I mentioned earlier, the dimensional weight of a package is determined by multiplying the length by the width by the height and dividing by a predetermined divisor, or dim weight factor is the term that you'll often hear. The billable weight of the package is then determined, again, by using the greater of the two weights, the dim weight versus the actual weight. UPS and FedEx and just about every other carrier these days, with a few exceptions, uses 139 as their predetermined dimensional weight divisor or dim factor. Now that number has not been pulled from thin air. What that number represents is the number of cubic inches per pound, and I'm not going to get too sciencey here, but the number of cubic inches per pound that allows the carrier to get to a predetermined minimum package density. So a divisor of 139 allows the carriers to get to a predetermined package density of 12.4 pounds per cubic foot. So there's a lot of analysis that went into that to that density number for FedEx and UPS for them to understand that 139 was the appropriate divisor. That divisor number has trended down over time. Back in 2007, when the carriers first started to dimensionalize ground packages, that divisor number was 194. Now that 194 allowed them to achieve a package density of 8.9 pounds per cubic foot. So you can see how as that divisor has trended downward, it has allowed the carriers to realize a higher average package density. They're at 12.4 pounds per cubic foot now. So let's look at an example to see how this dimensional weight formula impacts shippers. So let's take a package that has dimensions of 18 inches by 12 by 12. Let's say this package actually weighs 6 pounds. If you put it on a scale, it weighs 6 pounds. The dimensional weight of that package is 19 pounds, and we get that by multiplying 18 by 12 by 12, and keep in mind those are inches, 18 inches by 12 by 12, to get to a cubic inch number of 2,592. So that's 2,592 cubic inches. We divide it by their dim divisor of 139, we get to 18.65 dimensional pounds. The carriers round up, so they're going to round that package up to 19 pounds. So you've got a 6-pound package that has now been dimensionalized all the way up to 19 pounds. And because 19 is greater than 6, the carriers use 19 as the billable weight. So let's assume that package was a ground shipment, and let's assume it was going to ground to zone 5. And we're dealing with published rates here, not discounted rates. But if we go to the UPS 2020 rate guide, we can see that a zone 5 6-pound ground package would cost $13.50 to ship. A zone 5 19-pound ground package would cost $18.25 to ship. So that represents a 35% cost increase on that package due to those package dimensions. So why do carriers use dimensional weight? Why is it so important to them? Well, think about how carriers charge for package shipping. They charge by weight. So the heavier the package, the higher the rate. If you look at a sort of a typical FedEx or UPS net rate sheet, you'll notice very, very quickly that as you increase your package weights, you increase the rate on the package. So for that reason, small, dense packages are just naturally more profitable for the carriers because they can fit a lot of small, dense packages on a trailer or on a package car. The higher density means the carriers can charge a higher rate relative to the space that they occupy. So think about if you were shipping bricks. You can load up a package car or a trailer with bricks, and you're going to exceed the maximum weight capacity of that trailer long before you're going to exceed the maximum cube capacity. You're not going to fill it up with bricks. It's going to get too heavy too fast. So that trailer becomes very, very profitable for the carriers. They're carrying maximum weight. They can charge a premium on every single one of those bricks that they ship. Larger lightweight packages are less profitable. Think about a shipper that ships large cartons of feathers. Those large cartons of feathers are going to take up a ton of space on the trailer, but because they're very lightweight, again, remembering that carriers charge by weight, because those large boxes don't weigh a lot, the revenue that each one of those boxes generates is very low. Therefore, the profitability on that trailer, again, because they can't max out the weight of the trailer because those boxes take up way too much space. The revenue, therefore, the margin on that trailer is not favorable to the carrier. This is why the carriers have to charge by dimensional weight. And again, we talked about how it's become much more prevalent than it used to be. There was a time when UPS and FedEx didn't ship so much e-com volume. It was mostly B2B. B2B shippers historically are way more efficient from a packaging standpoint. They just don't ship a lot of air. As e-com became more prevalent, these shippers are less savvy from a packaging standpoint. They're not as efficient. They're shipping larger, lighter weight packages. The carriers had to adjust. They had to find a way to maintain profitability on their package cars, their trailers, etc. They needed to ensure that minimum package density, therefore they charge by dimensional weight. Why does it matter? Well, obviously a shipper has to understand dimensional weight so that they know how they're being billed. You can't understand your costs if you don't understand your billed weights. So understanding which packages are being impacted can help a shipper direct operational efforts appropriately. Are there package sizes that can be reduced? Are shippers shipping more air than they need to? Can that be fixed? Understanding billable weights ensures that shippers are charging their customers appropriately if applicable. So if you're manifesting a package at 6 pounds and you're passing that cost along to your shipper, not capturing the package dimensions and understanding that it's actually costing you the 19-pound rate, you're probably not passing along an applicable cost. And then understanding dim impact can help accurately direct negotiating efforts. If all of your packages weigh 6 pounds, but they're all being billed at a 19-pound rate, your negotiating efforts need to be focused on the cost of the 19-pound package, not the 6-pound package. So what can shippers do to mitigate the impact of DIM? Frankly, ship less air. Find ways to reduce package sizes. Get the air out of your boxes. Put 2 of everything in a box to achieve higher densities. Look at package optimizers if appropriate. If you're being killed by DIM, you're shipping a lot of air, you don't know how to fix it, look to a package optimizer to help you with that. Negotiate, negotiate, negotiate. Every aspect of DIM pricing that we've talked about today, DIM divisors, cubic inch thresholds, etc., can all be negotiated. DIM divisors can be negotiated upward, thereby reducing billable weight. The higher the DIM divisor, the lower the billable weight. Look at the impact that a cubic inch or a cubic foot threshold might have. Maybe your packages are all coming in just shy of 1 cubic foot, but they're all being dimmed. Put a cubic foot threshold in your contract that looks to dimensionalize packages that are only larger than a cubic foot and not less than a cubic foot. Make sure package discount negotiation efforts are focused on the build weight, again, as we talked about, not on the actual package weight. And the key to all of this is really robust analysis. Understand which packages are being dimensionalized. Understand the degree to which they're being dimensionalized. Use that analysis to make a really strong business case to the carrier as to why you need some help with mitigation efforts. And lastly, a third-party provider like a Shipware or many of the other competent players in this space can help you not only with that analysis, but help you understand what might be appropriate from a negotiation standpoint.